Preston Physics, Grade 11, Kinematics, Note 9, Acceleration Time Graphs. An acceleration time graph is the last graph that we're going to look at for this unit, where we have acceleration on the y-axis and time on the x-axis. When we're looking at this graph, just because we get down to the x-axis doesn't necessarily mean we've stopped, it just means we have no acceleration left. Now here, our starting point means we have some positive acceleration. Now in the first section, we are increasing our positive acceleration. So we have a positive change in our acceleration. Now the middle flat portion has a constant acceleration. It's not changing, but we're still getting faster. Something like gravity is a good example. Then we have a negative change in acceleration. The whole way down this line we're still accelerating, but the rate of acceleration is getting slower. Now, when we look at the slope for an acceleration time graph, it's a little bit different than what we were looking at before. Here, we're still going to focus on quadrant 1, and we're still going to look at the slope with respect to the direction of the slope and the steepness. If we have a positive slope, that's like pushing down on a gas pedal and increasing the speed more and more. Now, when we have a negative slope, it's kind of doing the opposite. We're still increasing the speed, but we're slowly letting off of the gas pedal now until we reach that speed that we want to get to. Now when we're looking at the steepness of the slope, now this is just talking about whether it's a quick change when we have a very steep slope, or if we have a shallow slope, a slow change in the acceleration. We're now going to look at the meaning of the slope for an acceleration time graph, just like we have with the last two sets of graphs. So we're going to have our acceleration and our time and then some line. The slope, again, is going to be equal to the rise over run, which is equal to the difference in the y over the difference in the x. Now in this case, we have acceleration for our y and time for our x. And then when we look at the units here, we actually get meters per second squared over seconds, which is meters per second cubed. And that's actually called the jerk of an object. It means like if you get jerked forward when you're on a roller coaster or something like that. It's something that is fun to kind of know about if you're going into physics, but it's not really important in grade 11, so you won't be tested on this unless it's a bonus type question. Now the final thing that we're going to look at with regard to properties of an acceleration time graph are the different types of slopes that we can have and how they affect our acceleration. If we have a horizontal slope, what that means is we're constantly accelerating at the same rate. So a good example, like we said before, of this would be gravity, where gravity constantly affects an object at the same rate. The second thing that we could have is either a positive or a negative slope, where we're moving the graph up or we're moving the graph down. In this case, we are looking at the jerk of an object. So we have a change in acceleration, which means that we have a constant jerk of this object. Then finally, we're going to look at a curved line, and now what this means is that we have a change in our jerk value. With this information, we can now make the acceleration time graph for the object in our lab. The question out of your yellow duotang for this section is number 26.